So here's another example where we can use the Quine-McCluskey method. And we're going to start again by drawing the ones table. So we're going to list our min terms as sorted by the number of ones they have in their input combination. These are our size 1 implicants. So with 4 input variables, we could have 0, 1, 2, 3, or 4 ones in our input combination. So this output has don't cares in it. Do we include that in our ones table? Yeah, we do. We include the outputs that have don't cares as if they were ones so that we can use them in combining. But then when we consider which min terms or which implicants need to be included in our equation, we will consider those x's as zeros because they don't need to be included in our equation. They can be if they help us, but they don't have to be included in our implicants that are forcing the ones. So to start with, we're going to interpret those x's as ones for our ones table. Don't cares, we're going to interpret as ones. Later, we'll interpret the don't cares as zeros. Okay, so again, we're going to include the don't care outputs, those min terms associated with the don't care outputs in our ones table so that we can use them for combining. Okay, so first of all, let's take a look at which min terms are going to be in our table. So all of these min terms are going to be in our table, where the output is either don't care or 1. So 0, we can see, yeah, we don't have that output, so there's nothing in this row of the table. So there are no size 1 implicants that have 0 ones or no ones. All right, what about implicants that have 1, 1? Well, here we have this one, 0, 0, 0, 1, 1, 2, 4, now we check 8, yep, and that's going to be it. Now we look at the input combinations that have 2 ones. Well, min term 3, min term 5 isn't included, min term 6 is, min term 9, min term 10, and the last one we would check was min term 12, but that output is 0, so not included. And now we look at any min terms that have 3 ones, where the output is either a 1 or a don't care. So 3 ones, the first possibility is going to be 7, but that output's a 0, so not included in our table. And then we look at other possibilities here. So 11 would have been a possibility, but the output is 0 again. Not included in our table. 13 would have been a possibility, but the output is 0. Also not included. But min term 14 is. And finally, we look for the last possibility. If we have 4 ones in our input, well, this is the only possibility, but the output is 0, so we don't have any entries in that row. So here written nicely, our ones table, we have our groups of inputs that have a single one, where the output is 1 or don't care, where the inputs combinations have 2 ones and 3 ones. So now we're going to use combining to make our size 2 implicants. These are implicants that include 2 min terms. And so we just start methodically from the top, check and see, does min term 1 combine with min term 3, min term 6, min term 9, min term 10. We'll start with min term 3. So these differ only in the C position. So in fact, we can combine those. And we get 0, 0, don't care, 1. That would correspond to A bar, B bar, D. C has been combined out. And we say which midterm we combined, midterms 1 and 3. Now we look at the next one, trying to combine midterm 1 with the next option. So now we're going to see if these differ. Well, don't differ in the A position. They're the same, that's good. They differ in the B position. Okay. And they differ in the C position. Okay, we're done. If they differ in more than one position, we can't use combining. They can only differ in a single position. So midterms 1 and 6 cannot combine. So now let's check midterm 1 and 9. They differ in the A position. They're the same in the B, C, and D position. So yes, we can use combining. We're going to get don't care, 0, 0, 1. So that's like A has been combined out, and we get B bar, C bar, D. And the last possibility for midterm 1 is combining with midterm 10. We can see that those differ in the A position. We could go on, they're the same in B, good, differ in C. We're done. They also differ in D, but after we've hit more than one difference, we're done checking. For combining, again, they can differ in only a single term, a single literal. Now we're going to check midterm 2 against each of the midterms in group 2. So 0, 0, 1, 0, these ones differ only in the D term. So we get 0, 0, 1, don't care. Combining midterms 2 and 3. Midterm 2 and 6, we get a difference in B. C is the same, and D is the same. So we can use combining here. We get 0, don't care, 1, 0. This is for combining midterms 2 and 6. Midterm 2 and 9, we check those. They differ in the A position. They're the same in the B position. They differ in the C position. So we're done checking. We cannot combine midterms 2 and 9. Now we check for midterm 2 and 10. They differ in the A position. They're the same in the B, C, and D position. In fact, we can use combining. We get don't care, 0, 1, 0. This is for combining midterms 2 and 10. Now we check the next one, midterm 4. Check it against midterm 3. We get same in position A, differ in B, differ in C. We're done checking. Those ones cannot combine. They can differ in only a single term. Midterm 4 with midterm 6. They differ in C. They're the same in A and B positions. They differ only in C. So in fact, we can use combining, and we get 0, 1, don't care, 0. That's combining midterms 4 and 6. 4 and 9. They differ in A. They differ in B. We're done checking. They differed in more than one place, more than one variable, and so we cannot use combining. Midterm 4 and 10. They differ in A, they differ in B, we're done checking. We can't combine midterms 4 and 10. They differed in more than one variable. Now the last one we check is midterm 8. So now we're going to look at midterm 8, midterm 3, differ in A, they differ in C, we're done checking. We cannot use combining. They differ in more than one variable. Midterm 8 with midterm 6, they differ in A, they differ in B, we're done checking. Cannot use combining. Midterm 8 with midterm 9, they're the same in A, same in B, same in C, differ in D only, we can use combining. We get 1, 0, 0, don't care. And that's for combining midterms 8 and 9. Now we check for midterm 8 and midterm 10. They're the same in A, B, differ in C, they're the same in D. They differ in only one term, So we can use combining. We get 1, 0, dash 0. This is for combining minterms 8 and minterm 10. Okay, now we're done. Remember that we only combine between adjacent groups. So group 1 with group 2. We don't try to combine group 1 with group 3. So now we're going to try to combine between group 2 and group 3. So in group 3 we only have one minterm, so that'll make it easy. Minterm 3, try to combine it with minterm 14. Differ, differ, done checking. So differ in the A and B positions. Turns out they also differ in D, but after I've found that 2 positions differ, I'm done checking. There's no way we can use combining. All right, so let's check the next one. Minterm 6 with minterm 14. Yep, these ones only differ in the A position. They're the same in every other position. So we can use combining on that one. Don't care, 1, 1, 0. That was for combining minterm 6 and minterm 14. Now we try minterm 9 with minterm 14. The same in position A, differ in B, differ in C, done checking. Can't use combining, they differ in more than one position. And minterm 10 and 14, they're the same in A, they differ in B, they're the same in C and D. We can use combining. We get 1, don't care, 1, 0, and that's for combining minterms 10 and 14. So now we have our size 2 implicants, and now we're going to use combining again, or try to use combining to combine between groups of size 2 implicants. So we're combining between this group and this group. In other words, this group, and that's the only possibility. We don't have any more in this group. So the first thing we want to do in combining is look at the don't care position. We have to match that don't care position. And here there's no term in this next group. In group 2, there's no term that has a don't care in the C position. So minterm, the implicant that includes minterms 1 and 3 cannot combine with anything else. We do the same thing for the other implicants in group 1. This one, there's a potential match here. The don't care matches up in the A position. And now we check the other ones. Well, they differ in B. They differ in C. We're done checking. They can only differ in a single position. So minterm 1 and 9 can also not combine with anything. Minterm 2 and 3 has a don't care in the D position. There's nothing down here that has a don't care in the D position. We have a don't care in the B position. Here's a don't care in the B position. Potentially we can combine these 2 implicants. They differ in the A position, and they're the same in the C and D position. So in fact we can combine those, and we get don't care, 1, 0. We combined out the A term, and we combined minterms 2, 6, 10, and 14 to get that size 4 implicant. It includes 4 minterms. Or in our K-map, it would have been a circle with 4 ones. Now we look at our next one. We have a don't care in the A position here for M210. M614 also has a don't care in that A position. So we can potentially combine those. They differ in the B position. They're the same in C and D, but we would have ended up with the same thing that we just had. Don't care, 1, 0. Minterms 2, 6, 10, 14. Again, that same thing we had last time where we have 2 vertical groups of 1s or 2 horizontal groups of 1 resulting in the same group of 4. So we're not going to include that. We already have it included in our size 4 implicants, so we don't need to include that again. It's already there. Check the next one. M4, 6. the implicant that includes minterms 4 and 6. We have a don't care in the C position. There's nothing down here that has a don't care in the C position. Again, remember to match that don't care first, and then use combining on the rest of the variables. Now we check this one. This one has a don't care in the D position. Again, nothing that has a don't care in the D position. And the last one has a don't care in the C position. Again, nothing in that next group that has a don't care in the C position. So we're done. So now we can no longer combine anything. There's nothing to combine with in an adjacent group. And so we're done with our ones table. Now we're going to look for prime implicants, not just implicants, but prime implicants, circles that are the largest circle that we can make. So here we have a prime implicant, clearly. This one is a prime implicant. And now we look for other prime implicants. M13 is prime because it's not completely included in any other implicant. M19 is also prime because it's not, those minterms are not completely absorbed by a larger implicant. M23 also prime. Minterms 2 and 3 are not included in a larger prime implicant. M26 included, that's not prime. M210 included in a larger prime implicant, so that's not prime. M46, oh, that's not completely included. Part of it is, the 6 is included, but not the 4. So M46 is prime. M89, also prime. M810, also prime. M614, not prime. It's included in that larger prime implicant. And M1014, also not prime. So now we have our prime implicants, and we can list them in our table. So our prime implicants table. Prime implicants table. And so we're going to list our prime implicants. Okay, so now we've listed all of our prime implicants. And now let's list the minterms that we need to have included in our equation. So we need the minterms that have to be 1 on the output. So now we're going to just look at the ones in our output function. The don't cares don't have to be ones in our output. They can be if they help expand our circles or if they help us minimize our equation further. But minterm 2, here's minterm 2, minterm 4, minterm 8, minterm 9, and minterm 14. So 2, 4, 8, 9, and 14 are the only minterms that have to be included in our equation. So now I'm treating don't cares as zeros. We use them in our our ones tables as if they were ones because we want to use them to expand our circles or to use them in combining like we did in that step. So now we fill in our minterms that are covered. So 2 is covered. Where's 6? I have a 6 here. Well, 6 was a don't care. So it's not a constraint. I don't have to have it in my equation, but it could be there. So 6 is not one of the minterms that I have to have. Neither is 10, but 14 is. So 6 and 10 clearly are don't cares because they're not in my constraints of minterms that I need to include in my need to cover in my equation. Minterm 1 and 3, gosh, that implicant doesn't have any minterms at all that are required for this function. Okay, well clearly minterms 1 and 3 were don't cares. Minterm 1 and 9, well only 9 is a required minterm that needs to be covered. Minterms 2 and 3, 2 is the only one with a 1. 3 is a don't care. 4 and 6. 4 is the only one that has to be covered. 6 is a don't care. 8 and 9. And 8 and 10. 10 is a don't care. And we can go ahead and fill in these from our table, from our ones table. So here we have our prime implicant table written nicely. And so now we need to figure out, well, which prime implicants do we need to include? So remember, the first step is to look at the minterms that are only covered by a single prime implicant. So in other words, these columns that have a single x in them. So minterm 14 is only covered by that top prime implicant. And here's another single x. So those two prime implicants definitely need to be in our equation, because minterm 14 and minterm 4 are only covered by those two respective prime implicants. But because this prime implicant is going to be included in our equation, for free, we get minterm 2 covered as well. And now we look at which minterms are not yet covered. So 2 is covered, 4 is covered, 14 is taken care of, 8 and 9 are not yet covered by any prime implicants. So we have some possibilities here. So M19 could be included, but that would only cover one of them, 9, minterm 9. M810 could be included. In fact, we could include, if we include both of those, M19 and M810, well, then we have minterms 8 and 9 covered. But it's better if we can just include one implicant, M89, that already covers both of them. So we don't want to, although this would be an option, it's not the minimal option, because it would require us to include 2 extra implicants instead of the preferred method, just a single implicant that covers both of those 2 minterms. Again, we look at our constraints, columns that have just a single x in them, so a single option for covering that minterm. And then we see what we get kind of for free with that. So 2 comes along with that, because we have to have this implicant included in our equation. We get 2 kind of for free, comes along with that implicant, that prime implicant. And then we figure out that, hey, I can include just that single other prime implicant to cover both of the other minterms that were not yet included in the equation, M8 and 9. And now for these prime implicants that we include in the equation, let's go ahead and write the terms, the implicant. This is C and D bar. This is A bar, B, D bar. And this is A, B bar, C bar. So A, B bar, C bar. And now we OR those terms together. Y equals C and D bar, or A bar, B, D bar, or A, B bar, C bar. And none of the other implicants are included in our equation. So here we have it typed out nicely for your convenience. And let's review what we talked about. We talked about the Quine-McCluskey method, history, and the process. We make the ones table, then the prime implicants table, and select our prime implicants. We went through a couple examples. And I want to reiterate what I said earlier. Quine-McCluskey takes longer than K-maps. Use K-maps when possible. So functions that have less than or equal to 4 inputs, use a K-map unless you're asked to use Quine-McCluskey. And in that case, even if you're asked to use Quine-McCluskey, use the K-map as a double check to make sure that your Quine-McCluskey worked out as it should have. So, for example, we can take the example we did with Quine McCluskey, example 2, and put it into a K-map instead. So we put this into our K-map. And so now we can use our K-map methods to figure out a minimal solution for this, because we have 4 inputs, A, B, C, and D. So, for example, we can look at this one right here. It's isolated in that we can't go left or right or down, but we can go up, wrap it around. So there's the only possible circle for that one. And we look at some other isolated ones to try to figure out what the minimal solution is, or the largest circle. So this one here can't go left, can't go down, could go either up or right. Okay, so let's take a look at this one up here. Can't go left or right. Could have gone up here or down, but again, this is the exact case. If we circle these two, even though we could have gone like that for that one, or this for this one, if I make that original green circle, we'll go ahead and take care of both ones. So now we can see graphically what happened here with that circle and this circle. Those were these 2 circles. But instead, we use the circle that covers both of the ones. So that's M8, 9. And the last one we need to cover are the ones on the bottom. And we can see that, well, this is the largest circle to cover those ones. So over here we have C and D bar. The red circle is A bar, B, and D bar. And this circle here is A, B bar, C bar. And we end up with the same solution that we did as with Quine McCluskey. Y equals C and D bar, or A bar, B, D bar, or A, B bar, C bar.